Good day, everyone. Welcome to Chemical Engineering G platform. Now, today we're going to be looking at material balances without chemical reactions, and we're going to be focusing on multiple units. So, in this case, you can see that you've got more than one unit. So, here is the first unit, and then you've got your second unit. So, we need to check and find out how do we determine the different values if we've got more than one unit and we do not have chemical reactions. So in the problem statement here, we can see that it says two-stage separation, and you can see this is the figure shown below. So now what we need to determine, F2, the value of F2. There's F2 there, and then you also need to determine the composition of F2. So the composition of F2, there's F2 there, F2. So how do we determine the composition of F2? Okay, so this is what we need to find. Okay, so the first thing that we must do is to write down the basis. So what is our basis? It's 1,000. Our basis is 1,000 pounds per hour. That's the first step, and then 1,000 pounds is F1. That's F1. So that's stream F1 there. Okay, so it's 1,000 pounds. So that's why we're taking the basis form. And then the second step is to determine the overall balance. Let's determine the overall balance. So now you go there and say overall balance. So now the overall balance is from the whole unit. Now we can check there. So which means our overall balance is going to move. This is the system boundaries for the overall balance. So okay, in equals to out. So now what's coming into the system? So we've got F1 is equals to P1 plus P2D. So what about that? Okay, let's choose the magnification. So it's P2D plus P2B. P2B. Okay, so what we're referring to is this. So here you've got P2B, you've got F1, you've got P1, you've got P2D. Okay, so the only variable in this equation that is known is F1 because it's that 1,000. It's 1,000 pounds per hour. So now we replace that. So 1,000 P1. That's what we do now. So P1 plus P2D plus P2B. So that's our first equation. Okay, and then now we need to go and conduct the component balance. Now, how do we conduct the component balance? It's important that we always look at the least appearing component. So if we go back and gauge closer there on our diagram, we can see that xylene, okay, xylene is only in stream F1 and P2B. So it's only in stream F1 and P2B. That's xylene. In that case, it tells us that xylene is the least appearing component. Therefore, using a component balance based on xylene is much more prudent. So we start with that component balance because we can easily find P2B if we use xylene. But if we use these other components now, we're going to have unknown in P1, we have unknown in P2B. Okay, so that's the wisest component balance to start with. It's least appearing because it's only in stream F1 and stream P2B. So now let's go and find that stream using the basic component balance. Okay, so now we just make sure easier, and then component balance. There, got our component balance. So the component is based on xylene. Okay, we're going to refer to xylene as XY. That's xylene. Okay, so now it's list appearing. So now let's write the component balance and let's use the variables. So X xylene, and so let's just remove that. It's a bit confusing. Okay, so now xylene in that particular xylene in stream F1. Okay, so this xylene is refer to it as XY multiplied by F1 is equivalent to X in P1 xylene multiplied by P1 plus xylene there in P2D multiplied by the total stream, which is P2D plus xylene XY in P2B multiplied by the total stream of P2B. Okay, so now we know that we do not have xylene in this stream, so we easily cancel out the stream here. We do not have xylene here in P2D. Okay, so if you go and check here, there's no xylene in P2D, so this one becomes 0. Also, there's no xylene there. Okay, so now our equation simplifies to that now. X xylene F1 multiplied by the total F1 stream is equivalent to X for P2B there, where xylene is found. Okay, so let's just go back there as a minor disturbance. So now you've got X of xylene there in P2B XY, and then you've got P2B. Okay, so now that's you can say that's your second equation, although it can easily be solved because now we've got only one known. So we know that xylene here is 0.2, which is 20% of the stream, multiplied by 1000, which is F1, is equivalent to 0.9 in P2B. Then P2B becomes the only unknown. P2B, okay, when you work that out, calculator, you'll find that it's 222.2, and that is pounds per hour. Okay, so you found P2B, but remember, you're not looking for P2B, you're looking for F2, and it's very important to always have that in your mind to say, this is what I'm looking for. So you're looking for F2, never forget that. So this is what you're looking for. We're just finding P2B so that we can get closer to finding what is actually required, which is F2. Okay, so now let's move forward. Okay, now here we've got to find the other values. Okay, so then moving forward, this equation 1 that we have here can actually be simplified because now we know two values. We know what P2B is. We know what P2B is. We also know this one, F1. So we can simplify this equation. So then we go back the equation 1. And simplified becomes, okay, simplified becomes 1000 is equivalent to P1 is equivalent to P1 plus P2D plus 222.2. When we simplify that, it becomes P1 is equivalent to 777. Just choose the subject of the formula. Subtract P2D. Okay, and just say that is equation 3. It's important for you to number your equations, even if you are not going to use them all, but it's very important so that you can know and track your steps. Okay, so now the component balance for benzene, because we need to find out the values in order to arrive to the final answer as far as finding F2 is concerned. Okay, so component balance of benzene now. Component balance based on benzene. When I use BZ, that's benzene. Okay, these are aromatic compounds. Okay, so now 3 into 4. So now we say equation 3 into 4. Equation 3 into equation 4. Okay, so the benzene balance, let's just illustrate quickly before we proceed. So now let's go back to our diagram. There is benzene there. Okay, so now hit the benzene balance. So you've got benzene here, F1 stream, you've got benzene here, in P1 stream, you've got benzene in P2D, and then you do not have benzene in P2B. Remember, we still follow the same thing. Check the least appearing component. So benzene is the second least appearing component, as witnessed from the diagram. So now we need to go and find P2D. So now we just substitute these equations. So the component balance here is X benzene F1 multiplied by the total stream of F1 is equivalent to X benzene P1, you got P1 there, plus X P2D is benzene there, multiplied by P2D stream. Okay, plus X benzene P2B multiplied by the total stream of P2B. Okay, so now automatically this will fall off because in P2B we do not have benzene. Okay, so now that reduces your equation. So you're going to focus on the 3, this one, and that one as well. Okay, so now you substitute. So in F stream, we know that benzene is only in the stream. What about that? Let's just remove it. So now in F stream, benzene is 0.4 multiplied by the total, which is 1000 of F1, equivalent to 0.99. That's the composition of benzene in P1. Now we said 3 into 4. So here we're going to use this equation now to substitute. This equation 3 comes into this equation. Okay, comes into this equation. So that's the equation that we're going to use. So it's the equation. We substitute into this expression. We substitute this equation. Equation 3. Okay. So here, I think it's prudent if we name this 4, so we do not get lost. So now you can see here that 3 into 4. Okay. Yes. So it's 99% the benzene. Okay, instead of writing the P, we know that P1 is equivalent. So P1 is equivalent to that. Okay, so substitution. So now 7.8 subtract P2D. Okay, and so we multiply by that expression plus 0.05 P2D. Okay, it's P2D. So now this expression reduces to P2D is equivalent to, if you punch work that out from the calculator, 393.6. That's pounds per hour. Okay, so now we've got the second variable. So we can easily get the third one, which is P1, since we have that expression there. Up there, we've got this equation here. So we can use it to find P1. Okay. So now let's use that one. So from equation 3, P1 is equals to 777.8 subtract 393.6. And what you get is 384.2. That is pounds per hour. Okay, so now we know all the variables. So what's left to find now is to just proceed and get the variable that we actually need. So which variable do we need? Okay, we want F1. So now it's easy for us to actually get F1 if we go back to our process flow diagram here. Since now we know P1, F1 we know, P1 we have, P2D we have, P2D. So we can actually conduct a balance around this unit to get F2, or we can conduct a balance around the second unit to get F2. That's still fine. Okay, so now let's go and check that one out. Okay, let's just go in and see if we can manage to get that, and then let's conduct a balance around unit 1. Okay, remember you can also use unit 2. So balance around unit 1. So the balance around unit 1 is F1 is equals to P1 plus F2. Okay, so that's equation 5. Okay, that's equation 5. Don't mix this one up. Remember, this is unit 1, not equation 1. Okay, yes, that's unit 1, not equation, but this is equation 5. Okay, yeah, so equation 5, substitute, we have the values now, so everything is just becomes simpler than before. So we know that F1, it's going to be, to find F2, it's going to be F1 subtract P1. Okay, so it's 1000 subtract 384.2. Okay, so let's see what we get there for F2. That's 615.8 pounds per hour. So we've answered the first part of the question. We're required to find F2, and F2, the amount of flow rate in F2 is 615.8 pounds per hour. So now we need to find the composition. What is F2 composed of in terms of xylene, toluene, and benzene? Okay, so now we conduct a component balance, okay, of toluene. Still fine. Okay, now component balance. Okay, so let's just bring that up first and then take it there. Okay, and there we are. So component balance based on tooling. Okay, so tooling will denote it as T for our variables. Okay, so now tooling on that unit, which is unit 1, the balance will look like that. F1 multiplied by F1 equals to X tooling in P1 multiplied by the total amount of P1 plus a mass fraction here, tooling multiplied by the total stream of F2. Okay, so that's equation 6. Okay, so now we substitute. We've got 0.4 totally multiplied by 1000, which is the initial flow rate that we're given, and then you've got 0.01 here multiplied by the amount that we found there. Okay, sorry about that, magnification error. Okay, now let's go back there. Okay, so now this is where we were. Okay, yeah, so let me just remove that. Okay, so now you said here it's 0.01 multiplied by the amount that we found, which is 384.2. Okay, plus X F2. This is totally. Okay, we know the total stream. We found it is 615.8. So now the only unknown becomes the composition of toluene. So that's what we're looking for. Okay, yeah. So now the composition of toluene in this instance, denoted as that in toluene in F2, becomes 0.643. Okay, so that's the first composition. So let's go now and find or determine the one for xylene. Remember, you can start with any component, even if you started with benzene. So component balance, benzene. So now it's component balance. Okay, of xylene based on xylene. Okay, so what do we do here? So in P1 we know that xylene is 0. So we just focus on the streams that contain xylene. So here we're going to have it's F2. Oh, sorry, we just go back. Okay, so the component balance, we're talking about xylene. It's gonna be F1 multiplied by F1 stream. Remember, this is xylene. So that's how we denote xylene. Equals to X of xylene in F2 multiplied by F2. Okay, so we know that this one is 0.2 multiplied by 1000 is equivalent to X xylene that we do not know. It's what we're looking for. Okay, I do not know that one. So X, oh, sorry about that. So X was xylene, and then F2, which is the unknown, but we know F2 is 615.8. So now what is the unknown? Okay, so X of xylene in F2 is given by 0.325. Okay, yeah, so it actually does make sense. Okay, because the column here, if you can check the column, you can see that the xylene in this case, okay, most of it will be recovered there. So xylene in F2 should be of minute quantities. Yeah, and then let's just proceed so that we can see what's the value of benzene. Okay, so now we just need to find benzene. Now that one should be very easy since we know that X of xylene plus X of toluene or plus X of benzene gives us 1. Remember the total of the mass fractions. Then 1 subtract X of xylene plus X of toluene, okay, gives us X of benzene. So X of benzene, or the component, the mass fraction of benzene in this case is 0.032. Okay, yeah, when you calculate. So now we have all the mass fractions, the composition in F2. Okay, so here we must add that F2. Okay, yeah, so here the composition of benzene in F2 is 0.032. The composition of benzene in of xylene in F2 is 0.325, and then the composition of toluene is 0.643. But now we need to tabulate that so that we represent it accordingly. So because when we want the composition, it's needed in percentage form. So you can just write there and say F2 stream composition or percentage composition, and you can write your components, and then you've got mass percentage. So here you've got benzene, you've got toluene, and you have xylene. Okay. So the total here, so benzene is 3.2, and then toluene is 64.3, and lastly xylene is 32.5, and this all adds up to 100%. So this is your stream composition of the F2 stream. Let's go back. So this is how you actually determine it. So now you've actually determined everything that you are required to do, but now always go back and check. So was this what was required of you? Yes, that was what's required. So the composition here, we found it. Okay, and we also found the amount. Okay, so that's very key. Composition and the value of F2. Thank you very much for watching. Let's just keep enjoying chemical engineering. See you next time.